All right, chapter 17, section 4, second part. In this one, we're just going to be talking about essentially when the electricity comes to your house, how we monitor it, how the power company essentially bills us. So first of all, electrical power, definition of electrical power is the rate at which electrical energy is changed into other forms of energy. So just like we've talked about all along, transfer of energy, law of conservation of energy, we cannot create or destroy energy. The energy that we just learned about that is produced in power plants, as it gets to you, it's just transferring. That's all we're doing. We're transferring energy, turning it into something else. So anything that uses electricity, anything in your house, computer, like you see on the list here, your TV, stereo, anything that uses electricity is really just taking that electricity from the power plant and converting it into electrical energy. It's just a transfer of energy. Remember that when this happens, just like any other energy transfer, heat is usually lost in the process. There is a massive amount of heat loss when you think about after that electricity is produced in the power plant, by the time it gets to your house, huge amounts of electricity are being lost. So all of our appliances, everything that uses electricity draws power, and it does so at different rates depending upon what it needs it for. Certain things in your house use way less electricity than other things. As you can see in the picture here, obviously your microwave uses a lot of electricity. They have a hair dryer in there. Shockingly, that uses a lot of electricity. Anything that's heating things usually uses a lot of electricity, like your dryer. Your dryer uses a massive amount of electricity. Refrigerators, big appliances, clearly they're going to be using more. To give you an idea of what that means, if you have something like a 100-watt light bulb, which is typical in a house, maybe a little bit less than that, but a 100-watt light bulb would use 100 joules of energy per second. So it's just a way for us to measure how much electricity is actually being drawn. Kilowatt hours are what the power company bills you in. So a watt is small. So even though I just gave you, an example of a light bulb, 100 watts, it's small. I mean, think of that. That's one light bulb in your house. When you start adding all of that wattage up for your fridge and your microwave, all of those things, it's a huge amount. So we deal more with a kilowatt. So remember, a kilowatt is 1,000 watts, kilo meaning 1,000. So a kilowatt hour is a unit of energy equal to 1 kilowatt of power used for 1 hour. So I'll say that again. The unit of energy equal to 1 kilowatt of power used for 1 hour. So if you use 1 kilowatt of power in 1 hour, that would be a kilowatt hour. It's actually a lot. It's a lot of energy. 1 kilowatt hour is equal to about 3.6 million joules. So it's a big number. If you would, just to give you another analogy here, because this is sort of a weird thing to think of. It's not something that we deal with normally. If you leave a 1,000-watt hairdryer on for an hour, you have used 1 kilowatt hour of energy. Or another way to think of it, that 100-watt light bulb, if you left it on for 10 hours, that would also be a kilowatt hour of energy. That's what you're doing. So it's just a way for us to measure energy, how much we're using it. So it's not always just, don't think of it how much energy is drawing, how long is it drawing for? So it's that multiple factor there, the two things. So when you look at the bullet towards the bottom here, number of kilowatt hours used, if you're trying to figure that out, take the number of watts used and you just multiply it for how long the appliance was on for. That's all. That's the easy way to figure it out. So electric companies will actually bill you for kilowatt hours used monthly. Just to give you an idea, average house in America is going to use probably around 800 kilowatt hours. That would be an average house. So it'd be interesting if you took a look at your power bill to figure out, where you're at. Obviously, if you are people who are conserving a little bit more, using appliances that don't draw as much electricity, that number can go lower. If you're people that leave the lights on all the time and you don't really use a lot of energy efficient things, then that number can skyrocket upwards as well. And always keep in mind here, like we just talked about, this is being billed to you. So this is money. So when you take this number, the more you can bring it down, the cheaper your electricity or power bill is going to be for you. So the power company is just keeping track of how many kilowatts you are drawing from your house and how long you are keeping it on for. And then they bill you. There's a certain number that they have. Every power company in the country has a rate structure set that they're going to use to say, well, okay, this is how much we're going to charge for each kilowatt hour. all of us have these on our houses. If you're getting power from a power company, it's a meter. I live out in the country. We have Lake Country Power, so they actually have a remote device set up. So this sends a satellite signal every single month to Lake Country Power to tell them. So they don't have to have someone come to my house. I know if you live in town, I believe the community still has someone, a meter reader in town that comes through and then measures that for you. The remote factor is actually kind of nice because obviously you're not paying someone that you have to go to the house to pull that information up. But that's all that meter does. That meter is reading for them how much electricity your house has actually been using. So just to give you a quick example of a problem here, if you wanted to figure out how much something costs to run, if you had a 100-watt light bulb and you left it on for 5 hours, and your power company charges 15 cents per kilowatt hour, which that's an average for our country, the cost of using, if you have it on for 5 hours, how much would that be? So you can actually literally figure out what it is per appliance there. So 0.1 kilowatts, 5 hours, that would be 0.5 kilowatts hours. And then if your power company charges 15 cents, you just multiply the two things together. So it costs you about 8 cents. One would think, oh, that's not very expensive. But remember, we're just talking about one particular light bulb. They actually have these really cool things, just so you know. You can buy them at Home Depot. You can buy them at Lowe's, Menards. If you plug them into the wall and then you plug your appliance into it and you type in what your power company charges, it will actually figure out for you, like it'll show you a number. It's a little readout thing that's kind of cool that says, hey, this is how much it's costing you to use this particular appliance. And like I said, if you're a person who is looking at maybe reducing some costs around your house, it's actually a really good investment because you can use it to figure it out. But that's all that they're figuring out. That's all they do. They figure out kilowatt hours used. What are they charging per kilowatt hour? And you just multiply the two together, obviously. To give you an idea here, if you look on the right-hand side, where we fit, so we are down here to the bottom for cost per kilowatt hour. There are some places in the world that it is much higher than that. Look at South Australia, look at Denmark and Germany. Now here's the interesting thing though, that's done. Germany has much higher amounts of solar energy, solar hot water heaters. It's almost standard in the country of Germany to have a solar hot water heater. And you can see why. You know, when the cost is such that it becomes cheaper to use that for homeowners, then it actually will sort of make that happen. Also, to give you an idea, if you're ever curious of where to find this information out on an appliance, every appliance, you know, they're showing you a toaster oven here, your dryer, they have a little metal tag on there. It'll show you on there what the power wattage is that it's drawing. So it's, you know, here it's on there. The other cool thing is if you go to stores now, instead of you even having to do the math, they have these energy guide stickers if it's an energy efficient appliance, and it'll tell you exactly, okay, this is the amount of estimated yearly electrical use per kilowatt hour. So this is what it's going to cost on average for you to run that appliance. So if you're looking at a couple of different, let's say you're looking at a fridge, you know, you can look at this sticker and go, you know, this fridge is going to only cost this much this year for us to run. This TV is only going to cost this much per year for us to run. So it's kind of cool that they put that on there now. It kind of saves the math for you. And just to go back to this graph here, you know, we have relatively cheap electricity. Even when you look at the United States, if you want to look at Minnesota, our electricity is relatively cheap compared to elsewhere. And like I said, you know, if that cost ever goes up, it makes you as a consumer start thinking about, hey, maybe I want to make sure I'm not, you know, doing certain things in my house to reduce that electrical use. So how to save money on electricity, the graph on the right-hand side here just kind of gives you an idea. This is a general amount here. It's from 2009, or it's been updated 2011, but this much really hasn't changed. So for the most part, you can look at 39.4% is used to heat the house. So what does that tell you? If you want to make the biggest impact, how can you do things to your house to make it so that you don't have to heat it as much? So electricity costs money for most of us. So you got to use less to save money. So how to use less? So I just mentioned heating. So don't move the thermostat a lot. You know, don't be finicky on, oh, I'm cold, I'm going to crank it up. Oh, I'm hot, I'm going to crank it down. You know, having the ability to put a sweatshirt on. You know, our thermostat, no joke, is pretty much always at 65. And some of you would be like, oh my gosh, that's really cold. I'm just used to it now. So we set it at 65. You put a sweatshirt on. In the summer, or in the winter time, make sure that you have the blinds open so that the sun's coming in. In the summertime, if it's really sunny out, you can shut the blinds so you're not heating your house up. Water heating is the next part there, conserving hot water. If you don't have to use the hot water, then don't use it. If you don't, especially for washing laundry, think about that. If you can wash in cold water, then wash in cold water. Turn things off when you're not using them. As a kid, I got yelled at constantly, turn the light off, when you leave the room. Yeah, turn the light off if you're not using it. Don't have things on if you're not using them. Unplug things. There's this thing that is called the phantom load, or the vampire load in terms of electricity. There's appliances that when you leave them plugged in, they draw a massive amount of electricity. Our cable boxes. For our house, if you guys have gaming consoles, if you leave those things plugged in and on all the time, they're literally just drawing electricity. So unplugging things if you're not using them. So besides the fact that it's cheaper, all of these things, when you're pulling electricity, if you're not using it, you're literally just contributing to, air pollution, burning fossil fuels for literally no reason at all. So there's lots of ways to save electricity in your house. So I just mentioned quite a few of them. Using energy efficient appliances is huge. LED lights, this particular thing has compact fluorescent, but LED lights are using insanely less amount of electricity as regular light bulbs. Their lifespan is much longer than regular lights. So switching just a simple few things over in your house, as time moves on here, can drastically decrease the amount of electricity that you are needing in your house. And by doing all of these things and just making them part of your daily life and becoming used to it, like I talked about with me with our thermostat, we're just used to it now. It's life. Other people might come in here and be like, it's cold, but they're not paying the heating bill. We are paying the heating bill. So doing these few simple things can really drastically reduce the amount of electricity that you need in your house, and essentially putting more money in your pocket.